Good evening, everyone. We are starting class now. So, in the previous class, we have discussed about some programming using Python programming. So, we are going to move ahead with some more programming concept that we are going to discuss over here. So, for that, we are going to use same tool, the Walkway tool, and over there we are going to start building the programs. Walkway that we have used earlier, that is online simulator. So, that we are going to use it over here. Walkway simulator. So in the walkway simulator, we are going to use that ESP32 board and we are going to program over there using MicroPython. So this MicroPython, we are going to use it. So I'm going to start with the project, new project, we are starting it. So new project that you can start it from over here. So this one is the basic program that we have done earlier. Now we are going to make some more program in the Python programming so that you can get familiar with the Python and how you can use Python for different projects. Like in yesterday class, we have discussed about like LED on off that we have done it, different condition we have used over there. So now we are going to use different like lighting, light automations, automatic door, many more project we are going to make it over here. So let's get started. So some project and some basic circuit we are making it and program we are writing it using MicroPython. Okay. So first project we made over there in the previous session that was for LED on off. Then after that we have made condition over there with the LED. Now we are going to move ahead with some more project over there. More sensor we are going to interface over there. And their value we are going to read it, and based on that we are going to make condition over there. So be with me, we are going to build some more project over there. Okay, so earlier we have used one PIR sensor. Now in replacement of PIR sensor, we are going to use simple button, and based on that button we are going to control the LED. So we are going to take LED and we are going to connect it with the button. Mean not directly, we are going to write code, and when we are pressing the button, LED should be on. So that we are going to make it over here. So first of all, let's make the circuit anode and cathode. So anode, we are going to connect it with the pins, 50 number pin, and we are going to take one resistance over there. So this resistance, we are going to connect it with this pin. So this one we have to connect with the ground. You can check that which pin is ground. So this one is a ground pin, so you can connect it with the ground like this. So that is simple LED that we have connected it over there. Now we are going to connect the button over there. So push button we have to connect it over there. So whenever we are going to connect push button, so directly we will not connect the push button, and we are going to make that circuit for the push button. Like earlier also we have used that push button circuit. So this push button is working in a cross connections like this one and this one. So like this one and this one. So what we are going to do, in Tinkercad we have done that circuitry. So that's the same circuit we are making it over here. So one is 3.3 volt ground. Okay, let me connect it over here. This one, this one. So one terminal we are going to connect with the ground, 5 volt. Okay, let me connect with one resistance. So this one resistance we are going to connect it with the push button. You can rotate it like this. Then this one we are going to connect it with the 5 volt. This one. Then after that, we have to connect one terminal over here, this one with the ground. take which pin is ground, ground we are going to connect it. So now we are going to take output from over here. That output we are going to read in different pin that is given over here. So I'm going to use pin D1, D0, 15, 14, 16 number pin we are using it. So I have connected from over here. This one is the pin. So that we are connecting it over there. So now we are going to write the code over there. So how we can write the code, that is very important. So in the same way like earlier we have used, we are going to use over here button, and now we are going to write code. So first of all, whenever we are going to write code over here, we have to write import. This one is the library that we have to use it. Import. So whenever we are going to use import library, so automatically color also get changed over there. And we are going to use machine library to import it. Then after that, we are going to use one option over here, button. So one variable we are taking it button, and over there I'm going to store the value machine. So this one we are going to take it library. From the library we are going to use pin number, pin we are going to define over here. So you can use this syntax. This one is the standard syntax that we are going to use it. So over there we are using pin number for the button is this one, 16 number pin. So we are going to use 16 number pin, and that we are taking it from the machine library dot pin, and we are going to use this pin as a pin. We are going to use it, and this pin we are going to use it as a input, input. So pin input. So this one we have defined it over here. Now after that we are going to use LED variable, and in the LED variable we want to give output. So these are the definition of input and output. So same thing we are going to use it over here, same line. You can copy it also and you can paste it. So over here we have to use pin number. So you can see the pin number of LED, that is 50 number pin. So you can use same pin number, 50 number pin, and that is for output. So over here you have to use out in a capital, in and out like this. So this one we have done it. Now after that, this one is about like button we are going to use it, and we have written code over there for that one. So now we are going to use some variable over there. We want to store the value of button. Like earlier also we have used one variable. So that we are going to use it in the conditions, like we are going to use over here while conditions, and we are going to take that variable and we are going to check that one. So now we are going to use while conditions. ये condition पहले भी हमने use की थी, while true condition we are going to make it over here. Then after that, what we are going to do it over here, we are going to use if condition over there. If, but before that, we have to take one variable, that is value is equal to whatever value we are reading from the button variable. So that value we are reading it. So that value we are storing it over here in this variable name value. So now on this value we are going to use if condition. If my variable value is, if value val is a variable, val is equal to double equal, we are using it, that is 1. So what we want to do over there, if this one is like this, so after that what we have to do, we have to make LED high and low, that we can do it over there. So LED variable we have taken it over there, LED, and their value we are going to use it, value, and the bracket we are going to use it, that is 1 or 0. 1 mean high, 0 mean low. Then after that we are going to use else conditions. So if condition we can close it over here, else condition we are using it. over here like this, else. In else condition, we have to make it same. LED value is 1. Like this. 1 is being replaced with 0. So in that way, you can write the condition and you can check it out how it will work. So we have used over here LED value 1. Okay. So pin input output button value we are taking it button value. Okay. Now after that we have to check it out, is it working or not. So this value we are reading it, so we can check it out and we are running the simulations. If there will be any error, that we can check it out and we are going to see how it will work. So we are going to make LED on and off, and pin number we have defined 15 and 16. 16 number for button and 15 number for LED, that we have represented over here. So now you can see hello ESP32, that is working, and LED is working. Now you can see without pressing that button we are getting LED on. So that is very important to understand कि आपकी LED को बिना प्रेस किए ही, सॉरी, बटन को विदाउट प्रेस किए आपकी LED ऑन हो रही है. So what we are going to do over here is we are going to press the button. What going to happen? LED is turning off. This one is working in a reverse order. When pressing the button, LED off, otherwise LED on. So what you can do, you can change the value over here. You can make it 0 and you can make it 1 like this. So now it will work in a same order whatever we are doing it. So in the same manner it will work. When we will press the button, LED will be on in the same way. So that we can make it easily simple program using that one. And if you want to add on sleep over there, that sleep delay also we can add on over there. Now you can see button pressing, LED is turning on, otherwise LED is turning off over there. So that we can do it in a very simple way like this. So now what we are going to do, if we want to control LED brightness, so how we can do that? So if you want to, this one is LED on off simply, just we want to give analog output. As we have discussed earlier, in the coding, there is 4 concepts. One is input, then after that output. And when we talk about the input, in the input, there is 2 parts. One is analog input and second is analog output. So we have discussed over here that is digital input and digital output. Now we are going to talk about analog output and analog input, how we can use that one, that we are going to discuss over here. So this one is same code. We are going to use over here analog in replacement of this one. So few modification we are going to do over here in the code. What modification we are going to do it? We are going to import time library. So time library we are going to import it. So you can use import. So import what you want to import it, new time library, that we are going to import it over here. Later on we are going to use that library for input and output over there. So now what we are going to do, we are going to use like a PWM output we want to give it to the LED. So that we are going to do it over here. So how we can write analog output signal, that is very, very important over there in the code. So we can use over here PWM like analog output, and we can use directly PWM over there. So that we are going to use it, be with me. So we are going to use PWM. So whenever we are going to use over here PWM, so we are going to use over here that value we are going to use over there. So what value we are using it? So analog output we are using it. So ADC we are going to use it over there. So that we are going to use over there. So let me check that PWM value. So how we are going to write it. But before that, we can read analog input also, like ADC also we can use it over here. So wait for a moment. Let me use in replacement of this. What we want to do? We want to while true. So we can use analog right over there. So that I'm just going to do over here. Be with me. So analog right, we want to do it. So which pin we are using it? PWM pin over here. That I'm going to check it out. First of all, the pins that we have to use it as a PWM pin. Wait for a moment. So we have to use over here that is that ADC that I'm going to check it out which ADC we are using it in the micro Python that we have to check it out. Because in the micro Python there is the different syntax we are going to use it. Okay, now we got it. So the PWM technique we are going to use it over here. So we are using over here ESP32 board. So there are some dedicated pins that we can use it for PWM output over there. So first of all, when we are going to use PWM right over there, we are going to create a different we are going to use over here import math and all that we are going to do it. Let's see a simple code. This one is print. Okay. So first of all, whenever we have to use it, we are going to use simple defining like import machine library that we are going to use it. And then after that, we are going to use some variable over there. So this one is a time that we are going to use it. Then after that, PWM, I'm going to use it, one variable. So in the PWM, we are going to use pin number definition. So for that, we can make it equal and machine library, we are going to call that PWM. Dot PWM should be capital PWM. And then after that, we are going to use pin number, whichever pin we are using it. So let's suppose there are different pins. So I'm going to use over here ESP32 17 pin. Let me use. So this one is 15 pin also might be work for the PWM. Let me use 15 number pin. So this one you can remove it. Right. So now button also you can remove it. Only directly we are giving PWM signal to that particular pin number. So P12 PWM pin machine we are going to use it and pin number we are going to define it over there like this. So that we have created over there. So PWM this one we are going to use it over here pin 12 and in this PWM also we have to use one more object. So directly I'm going to use that object over here. That is machine dot pin we are going to define it over here and that pin is we are using 12 number pin. 12 number pin and that is closed. Machine pin number 12 that is closed over there. So in that way, we can define like PWM value. So this one is declaration of the pin number, like earlier we have done for the digital output. So then after that, we have to set the frequency of the duty cycle, that how much value of duty cycle we have to write it over there. So there are different, like whenever we are going to use a duty cycle that range from 0 to 1023 over here in this ESP32. In Arduino, when we are writing analog output, we were using 0 to 512. But over here, we are going to use it, that is 1023. So 1023 means 0 to 10023. So when we are writing 1023, it means we are going to give 100% output. When we are writing half value, it means we are giving 50% output over there. Based on that, we can use it over there. So now what we are going to do, we are going to use a frequency that we are going to define it over here. And then after that, we are going to increase the brightness and decrease the brightness, that we can do it over there. So now this one is, we have defined over here PWM. Now we are going to set the frequency over there. So how we can set frequency over here? So we are going to use the same PWM over here, and then we are going to use frequency. So their value we are going to define it over here. So 500, we are going to define it, frequency 500. That in hertz and kilohertz, that we can define it. Then after that, duty we can define it. So duty we are going to define it over here, PWM dot duty. Duty mean how much percentage duty cycle we are writing it over here. So 512, that is half of 1023, that we are going to define it. So this one is PWM and duty that we have defined it over here. So now after that, we can move ahead over there, and we can use and we can run that code also over there, and then that code will work over there. So this one is initialization that we have done it. I mean the duty cycle we have defined over there, and then we have defined over here PWMP, and this one is a duty that we have defined it. Now what we are going to do, we are going to use this like LED variable, like earlier we have used it. So the pin number is 12, we are using it over here. So over there we want to write it, that PWM value. So that PWM value we are going to write it over there. So be with me, I'm just going to write the code. Wait for a moment. So these are the two things that is important whenever we are going to use that duty cycle. So over there, we are going to use the frequency definitions, and then after that, the pin that we are using it over here and their frequency that we have defined it over here. So now what we are going to do, we are going to make some condition over there, and we are going to uh, turn on and off that LED, or we can change the brightness of that LED. Okay, so PWM frequency, okay, LED, we have used over here PWM, and the PWM pin, we have defined it. PWM frequency also we have defined it. For loop we can use it, LED. So now we are going to use while true, and over there we are going to use LED, not LED, PWM, whichever we have defined earlier, dot duty, and we can use duty cycle over here. Duty cycle, we can set it any value, we can define it over here, like 400 or 512 we have already defined 512, this one. Then after that we can use sleep, and that should work over there. Let me check it out, that is working or not. So this one is the delay, 0.5 second. So this one is only one value we have defined it. Now let me check it out, is it working or not? Pin number 12 we are using it. This one is pin number, sorry, 15 we have to use it. Let me check first of all this code is working or not. What error we are getting it over there. Then we are going to correct this one. So it's saying that sleep is not defined over there. Okay. So directly that sleep is being not get defined. So we are going to use over here u time dot sleep, u time dot sleep. So let's see what error is coming. So we can resolve that error. Hello world, that is working. So now what we have to do over here, we have to use the same pin number. You stop the code. Pin number we are using 12 number pin, or this one is 15 number. So you can use over here 50 number pin. So in the 50 number pin, we are writing it. So 512 mean 50% duty cycle. Mean LED will be 50% on over there on that particular pin. So now that duty cycle, you can change it also based on your requirement. Like if you want to make it like 0 to maximum, LED will be on like that. So now this one is 50% on. So now if you want to use for loop over here, so I want to use one for loop. For loop mean your value should change 0 to 1023. ये वैल्यू आप 0 से 1023 तक चेंज भी कर सकते हैं. So I'm going to use over here for loop, and for that we have to use for, and I'm going to define duty cycle over here, one variable. So we have to take one variable over here with the name of duty cycle. Duty cycle. And their range we are going to define it over here in the range of in, and we can take range. So that range we can define it over here. So the range we are going to define it 0 to 10234. 1023. This one is the range that we have defined it. Sorry. So now we are going to define the range over there. So now what we are going to do it. So we are going to use over here PWM and duty. Sorry, the line already written over there. PWM and there duty, and after that PWM dot duty we are writing it, then duty cycle. This one is the variable. Their range will change from 0 to, sorry, control Z. Their range will change from 0 to 1023. 0 to 1023. Then after that we can use the delay. And delay we are using it over here in this for loop. Okay. So in that way, what you can do, you can define your duty, and you can execute your code. So this delay we have to reduce it so that we can see the timing changing very fast. 0.5. So that we can see it. अब हम चेक करेंगे कि हमारी एलईडी की ब्राइटनेस चेंज होनी चाहिए 0 से मैक्सिमम तक. So LED brightness should change from 0 to maximum. ESP, so you can see LED over here. So we are not able to observe the brightness. So let me stop it. So we can adjust this value to, let me make it 220 ohm. So that we can see properly brightness. So now let's run it. So now what is happening over here, might be we are not able to observe it. So LED brightness will increase from 0 to maximum, and it will reduce it in that way. So in that way, what we can do, we can run it and we can use it. So that is about it. So now we are going to talk about analog reading, how we can read analog signal. So that is very important that we are going to discuss it over here. So over there only one LED we are using it. Now we are going to use potentiometer over here and we are going to read analog signal over here. So we are going to use analog pin and based on that we are going to read signal over here. So in ESP32 pin number 0, you can see the pin number 0, ESP0, 2, 4, 12, 13. These pins are working as a ADC pin. Analog pin you can use it and analog output pin also you can use it. So there is a 12-bit resolution over there. Earlier we have used in the Arduino that was 10-bit resolution. So resolution now we are having 12-bit resolution in the ESP32 board. So that is the small difference over there. So when we talk about Arduino and when we talk about this one, what is the difference over there? That I just want to share over here. So let me discuss that one in a whiteboard. Wait for a moment. Okay, so when we talk about the whiteboard, okay, that we can do it over here. So now we are going to talk over here about the important thing that when we are going to use Arduino, in Arduino we are reading analog signal that is 0 to 1023 over there. But when we talk about that ESP32, over there when we are going to read it analog signal, so that ESP32 will read it in the format of 4095. Why that is 95? So when we talk about this one is 10 bits, so we can take it 2 raised to power 10, that is 1023. And when we are going to take 2 raised to power, that is 12 bit, 12. So that you are going to check it out, that will be 4096. So in that way it will work. And the voltage range is 0 to 3.3 volt because it work on 3.3 volt like this. So in that way, we have to write code over there in the ESP32. So now that is the resolution bit that we are going to use it over here. So now we are going to connect potentiometer over there and we are going to program it that how it will work. So we are going to use potentiometer and we are going to program it using MicroPython. So let's get started over here. We are going to write code in the same way. Okay. So the code we are going to write it over here. So you can erase this complete code or you can leave these two lines because that is required over there. So we are going to import it, import machine. Then after that you can import pin also, like different pins you can import it. ADC also you can import it. So that you can do it. So first of all, we are going to import machine over here, machine library. And from machine, we are going to import pin. So that also we are going to do it. So let's see. Machine we are going to import and from machine library, we have to import pin also. Import pin that we are going to import it and we are going to import ADC also. ADC library also we have to call it. So from you can import uTime library like this, or directly you can call it time library from the machine also you can call it. Like, let me check it out if that is working. So we are going to import over here from time. Time we are going to import. So there are different ways with the help of that you can write it. This one is a sleep, we are importing it. So now when we are using sleep, so we no need to use that T sleep or something like that. Directly we are using it. Now we are going to use over here one variable. We are going to take it port. And in this variable, we are going to read ADC value, and the pin number we have to define it. So we can use over here pin. We have to write it like this pin and then like this. And the pin number we are going to use it over here. Any pin you can use it. So there are different pins like 27, 29, 30, 30. Let me take this 34 pin number like this. Then after that, this one is the port variable we have taken it. Then we are going to uh, read ADC over there. We are going to read ADC value over there. So that is very important to use it over here. So we are going to use one syntax over here for reading this value that is required. So the syntax is port. This one is a pin definition that we have done it over here. Then we are going to call one library attentions about the pin ADC. ADC we are going to make it enable, and we are going to make it attention ATT and attention underscore. That is syntax for calling the library of this one. Library of ADC. So then after that, this one is simple we have used. This one syntax we have to write it for calling the library of ADC and defining it over here. Then we are going to use while condition, while true. Like earlier we have used. So while true, we are going to use semicolon, these columns. Then after that, the variable port value that we have used. Earlier we have used port now over here. Now we are going to use port value, another variable, port value. This one variable we are going to use it. Then after that, we have to make it this port, we are going to read it. So we are going to use port and we are going to read the value, read. And over there, we have to leave it empty because pin we have already defined over there in the port. You can see in the port pin is defined. So no need to define it again and again. So this one value we are reading it over here. And now we have to print this value. That is very important. Directly you can print it. So print what value we want to print it over here. We are going to print this variable value port underscore value. This one. So this one value we want to print it over there. Then after that, we can use delay that we are going to use it over here. Directly you can use sleep now. Earlier we have used a sleep, so you can use simply sleep because already we have called that sleep from the library. So both will work like earlier we have used, and this one also that will work over there. So in that way we can use it over here. So we have defined pin number over here and we have defined their ADC. So this one we have used syntax over here for reading the range from 0 to 14095 in this full range. It will read it using full range over here like this. So 11 is representing over here, that is the DB. That is the DB that we are going to read it over here. So that is the internal library function. No need to go indulge in the detail. That is the internal functions. Now we can check it out how it is working. So which pin we are using it over here for analog read. Let me delete this one. You can take photo, whatever circuit we are making it. So we are going to use potentiometer, port, 3 pin is there, VCC. We have to connect it with 3 volt, 3.3 volt. Because ADC we are using it, that is 3.3 volt. This one. Then this one is signal and this one is ground. So ground we can connect with the ground. Wherever you are going to find ground, you can connect it. GND, ground. Then the signal wire we have to connect with the pin number that we are using it 34 pin number. So this one is 34 pin. We are using it for the signal. Now after that, this one we are going to make it and we are going to print the value on the serial monitor and we are going to check it out how it will work. What error we are going to get it over there. So complete code we have written it over here like this. So now we are going to run this code. Let's see what error is coming over here. So right now we are reading and we are printing value on the serial monitor. So there is some invalid syntax over there. Let me check it. Line 3, 1, 2, 3 from machine pin. Okay. So main dot py file, main file, there is some error. So that we are going to resolve it over here. So we are using over here ADC from we have imported machine. We have imported ADC from machine. You can import. Let me do some modification over here. Import ADC from machine. Okay, so import first of all machine. From machine we can import ADC. First of all import machine. From machine we can import machine. Import ADC. That way also we can do it. Earlier way is also the same way, but we are trying with a different way. So we have imported ADC over here. And then after that, from time we have imported. From time to, let me make it U time. Because different, sometimes the syntax is different. So we have to use import before pin. Okay, let me check it out. So this one we are using it from your time import slip that we have also imported. Otherwise, if we are not going to use this one now, we have to use over here in the code in a detail. So now after that, rotary angle, port, we are using it, import slip, we are using it. ADC we have imported. Pin number is 34 that we have defined. ADC, okay. Now that is okay. Now check it out. What is happening? Is it working or not? So what error is coming that we are going to check it out. 20. Pin is not defined. So the pin error is coming now. So we have used over here pin. Port ADC we are using it. Let me remove that pin one. Directly we are using that port. ADC we are defining it. Let's see if it is working or not. In ESP32. ADC. Because when we are using that ESP32, there are some pin configuration. There are different way of defining it over here. Let's see what error is coming. Now it is working, that you can see. So you can see the value is coming over here, that we are changing it. Now we are changing the value. That value you are going to see on the serial monitor. So we are reading maximum value that I told you 4095. And the minimum value we can see it over here like this 0. So this one is working like this. So whatever the value we are giving it to this board, that is 0 to 3 volt, because we have connected it to the 3 volt, 3.3 volt. So maximum voltage signal we are giving from this potmeter to this board is, that is 3.3 volt. But we are reading this value in the format of scale up format, that is 4095, that you can see it from this one to 4095. So in that way, what we are going to do, we are going to magnify the value. So this value is being get magnified over there. So this ADC will depend upon a different board. Like we are using Raspberry Pi board, so their ADC will be different. That can be different, like 16-bit ADC is being used over there, so their value will be different over there in the Raspberry Pi. But the configurations, pin connections, like pin reading, that will be like this, and the potentiometer connection will also be like this. In that way, we can use potentiometer over there. So that will be in the same manner over there. Now we can use some condition also based on this value. Like we are reading this value, printing this value. Based on this value, we can make some condition also over there. If condition, else condition, whatever condition we want to use it over here, that also we can make it. Like I'm going to make if condition over here. If port this value we are reading it over here, port value. So over there I want to implement conditions. If I'm going to use it over here, this variable port value, their value is, if this value is greater than equal to, you can make it greater than equal to, or you can make it greater than, let's suppose that is 2000. So what you want to do? The value is greater than 2000, what you want to do over here, that we are going to discuss. So we are going to make LED on. LED is already there, so we can use LED on. So we are going to use LED, and over there we are going to use the value, like earlier we have used LED value, and that value we are going to define it 1. And in else condition, what we are going to do it over here, we can go back, take else condition over here. In else, we have to make the value of LED will be 0. So LED value is 0, that we are going to make it. Now what more we have to do, this LED we are using it, that we have already deleted from the code. So that also we have to define it over here, LED pin, which pin we are using it over here. So for that, I'm going to use over here one variable with the name of LED, and over there, which pin we are using it, that we have to define it. So we are going to use pin, that we are going to define over here, LED pin, and their value we are going to use it. So pin out, input or output, that also we have to define it. So let me check it out. Here pin. So in the pin we are going to use 60 number pin. Let me check it out. The pin number 50 number pin. 50 number pin we are using it over here, comma, and we can make it output pin. Pin is a output. Output is a type. Output. Out. You can write over here out. O-U-T. So that is output pin we are using it. So now over there we are importing ADC, and also we have to import pin from the code. We are going to import that pin also. so that we the error can get erased over there from the machine library that we have to import the pin. Then after that, what we have to do, this one is being defined, everything. Now the LED is also defined pin number and pin is output type. So that also we have defined it, pin dot out. So now we are going to check it out, the code will work or not. So LED is already connected. So when we are going to rotate it, so when the value will be more than 200, LED should be on, otherwise LED should be off. So this one we are going to do it. Check it out what error is coming and is it running or not. So some error is coming in line 12. LED value. So we are using LED dot value and indentation level match without indentation level. Okay, some this one is while condition, that is okay. LED else conditions if if else so implementation is okay. Let me check it out, is it working or not. Again, we are using only one delay over here, so we can make it 1 second because that is very less. So let's see what error is coming. Delay match in outer indentation level. So there is some error over here. Trackback most recent file last. Okay. So let me correct it. So first of all, let me use that delay is 1 second here. Okay, so print we are using it, if condition we are using it over here, and then we are using else. In the else we have to use this one. Colon over here, then check it out again. What it is saying. If conditions, else conditions, while true that we have written it. So let's see what error is coming. Indent doesn't match with the outer intent level. Okay, you can also find out the error over here. What is the error? So it's saying some error is over there. While true, what value we are taking it over here. So this port variable we are reading it, printing this port value, whatever we are reading it. Then we are using if conditions. So if condition we are going to use it inside it. If this sensor value is like this, then we can use LED high, that is okay. Then else condition we are using it, if then else, then we are using this one. So code look okay. So you can also check it out what error is over here. Else block we have to check it out in indentation way. Okay, if block and else block is not matching. Okay, let me check it out. If this one else not like this. Look okay, what is the issue over there? Okay, let me check it again. LED else sleep. LED value we have written it like this value, that is okay. Okay, sleep indentation is also looking okay. Let me remove that sleep if that is creating issue. Now let me check it out code. So that you have to do troubleshooting over here properly, that what error is coming over there, how you have to write the code properly, that should work over there. If condition we are using over here and we are using, now it is working. So that issue was occurring with the sleep. So this one you can see over here, the value we are reading it now. When we are changing the value is 800 or something. Still LED is off over there. Now, as we are going to increase this value more than 200, so LED is turning on now. So it will get updated over here, that value that is increasing. You can see in the serial monitor. सो जैसे हमारी वैल्यू 2000 से ज़्यादा होगी हमारी एलईडी ऑन हो जाएगी, दैट यू कैन सी इट, अदरवाइज एलईडी विल बी ऑफ. सो इन दैट वे यू कैन सी द एलईडी इज ऑफ नाउ, दैट you can see over here. So in that way what you can do, you can use potentiometer to read the value, and based on the potentiometer you can make your conditions. Condition mean you can use like this potentiometer we are reading it, and based on the sensor value, potentiometer value, we are turning LED on and off. So earlier we have done the same thing with the Arduino in a very simple way, but over here we have to take care about the coding. If you are comfortable with the Python coding, you can easily do that. So that is up to you where you are comfortable. If you are more comfortable with the C++, you can use C++ also. Otherwise, you can use this one also over there. Now, after that, we are going to control servo motor. So servo motor, we are going to control it using this one, using potentiometer. Based on the potentiometer, we can control servo motor also, and we can run that servo motor also. So that we can do it using that one. So that we are going to do in the next session. So today we are going to sum up the session over here. So we have discussed about analog input and analog output. Two things we have discussed over here. So that is very important. Then after that, we are going to start building project based on this Python programming in the workbee using this ESP32, and we can use that Arduino, that sorry, Raspberry Pi Pico board also, that we are going to use later on. So thank you so much. We are going to sum up this session over here. Kindly try to do some practice over there on the ESP32 board.